Hey there, curious minds. Ever wonder what happens to that click you just made? Or, the data you entered into a form? Today, we're pulling back the curtain on something absolutely fundamental to the digital world. The incredible, often invisible, journey data takes. How it goes from its raw form, just bits and bytes, to becoming this, powerhouse for decision-making.
Indeed, we're going to embark on a deep dive into the very lifeblood of modern organizations, the data lifecycle. It's a meticulously managed process, really, and it underpins nearly every significant business decision, every audit, every deep analysis in our increasingly data-driven world. Think of it less as a simple flow chart and maybe more like mapping the intricate DNA of information. It reveals its entire lineage, its purpose, and its eventual resting place.
That's a perfect analogy. Yeah. And you've sent us some absolutely brilliant source material on the data lifecycle. So our mission today is to unpack every single bit of it. We'll trace data's fascinating path from its very inception, like its conceptual birth, all the way through to its strategic application and, ultimate retirement. We'll explore why each stage isn't just important, but critical, and uncover the diverse ways data gets collected in the first place. Our goal is to give you that truly informed aha moment about how companies effectively and responsibly manage what is undeniably their most valuable asset. Okay, let's unpack this. So let's start by setting the stage. Data at its core. It isn't just rows in a spreadsheet or lines of code, is it? It's fundamentally the engine of decision-making for, virtually every organization today. Without truly understanding and leveraging it, businesses are really just kind of navigating by guesswork.
Precisely. Data plays an indispensable and critical role, particularly in the realms of auditing and strategic analysis. It forms the bedrock, really, upon which reliable insights are built. It allows companies to move beyond intuition to fact-based strategies. What's truly fascinating here is the sheer pervasiveness of data generation in our modern world. I mean, it's everywhere. It's no longer just explicitly entered information. Data is continuously being created through countless, often unseen avenues. Consider every time you make an online purchase, that single action generates a cascade of data within transactional systems. Everything from your payment details to your shipping address, your product preferences, it all gets recorded. Or think about the vast amounts of information produced by advanced technologies like artificial intelligence. AI is constantly learning, processing, and generating new data from patterns it observes. Then there's the burgeoning Internet of Things, or IoT, where everything from your smartwatch tracking your steps to industrial sensors monitoring factory equipment, it's perpetually streaming data, often in real time. And of course, despite all this automation, there's still a significant amount of manual input, like a customer service representative keying in details from a support call. All of this constantly and relentlessly contributes to an ever-growing, exponentially expanding ocean of information.
It's truly astounding when you think about the volume and velocity. Just wow. So with this deluge of data swirling around, it becomes an absolute corporate imperative, doesn't it? Businesses must understand not just what data they have access to, but also the immense responsibility that comes with using it wisely, securely, and ethically. You can't just collect it and let it sit there, or worse, use it improperly. This leads to a crucial question. What does this all mean for businesses trying to make sense of this overwhelming flow?
And this brings us directly to our topic, the data lifecycle. It's far from a mere theoretical concept. It's a vital guiding process. It helps organizations manage their data responsibly and strategically from its very inception, the moment it's conceived or acquired, right through to its ultimate secure disposal. It's the framework that brings structure, governance, and accountability to what could otherwise be a chaotic, risky, and incredibly costly endeavor. Without such a cycle, data can quickly become a liability rather than an asset, riddled with inconsistencies, security vulnerabilities, or simply being irrelevant.
Which naturally brings us to the data life cycle itself. Our sources describe it as a sequential journey that all business data, ideally, should undergo. It's not just a pick-and-choose menu of activities. It's a defined, interconnected path, right?
That's absolutely right. This comprehensive process can be summarized into 8 distinct steps. They form a complete roadmap for how data is handled throughout its entire existence within an organization. These steps are, in their logical order: definition, capture, preparation, synthesis, analytics and usage, publication, archival, and finally, purging. If we connect this to the bigger picture, these stages ensure that data isn't just collected arbitrarily or left to languish. Instead, it's purposefully managed to truly serve its intended purpose across its entire existence, maximizing its value, maintaining its integrity, and ensuring compliance at every turn. Each stage is meticulously designed either to add value, maintain quality, or, efficiently manage the data's entire existence.
That's our roadmap for this deep dive. We're going to go through each one step by step to truly understand not just what happens at every stage, but critically, why it's so crucial for a business's success and integrity. Imagine a single sales transaction, like someone buying your company's new AI-powered smart speaker online. That one interaction is a tiny speck of data, right? But it's about to embark on this grand, meticulously managed journey. We'll trace that specific transaction's data through each stage, seeing how it transforms from a simple input into powerful business insights, and eventually, how it's handled at the end of its useful life. All right, let's kick things off with step one, definition. It sounds almost deceptively simple, like just deciding what data you need. But this is truly where the strategic foundation is laid, isn't it? It's the blueprint phase for every subsequent action.
It is indeed foundational. The definition stage is paramount because it meticulously determines what specific data a business requires. And perhaps even more crucially, where that data will be sourced or retrieved from. Without this initial clarity, organizations risk collecting irrelevant, redundant, or, well, noisy information, which can lead to wasted effort, misallocated resources, and ultimately skewed analysis. It's like, imagine trying to build a complex, multi-story building without a detailed architectural blueprint. You wouldn't know which materials to gather, where each component fits, or even if the structure would stand. This early clarity directly and profoundly enhances the likelihood that the chosen data is, in fact, precisely relevant to the specific data collection goals, preventing those downstream problems.
Right, avoid the junk data from the start.
Exactly. Let's consider our smart speaker company again. If they want to improve customer retention, the definition phase would involve determining precisely what customer behavior data is relevant. Is it just the initial purchase history? Or do we also need website interaction data, app usage patterns, maybe customer service call logs, perhaps even demographic information from customer profiles? And then, where will this data come from? Internal CRM systems, web analytics platforms, or perhaps external market research databases. Getting this right up front isn't just about efficiency. It's about ensuring that every subsequent dollar and hour spent on data processing is directed towards achieving tangible business value. It involves deep collaboration between business stakeholders, data strategists, and technical teams to ensure alignment between business questions and data availability.
So once we've meticulously defined what data we need, the next logical and essential step is to actually get our hands on it, to bring it into our systems. That's capture or creation. How do we actually make this data a tangible reality within the business?
Right. This stage is all about the acquisition of data, and it involves a fundamental distinction between internal and external data acquisition, each with its own set of considerations. Internal data, as the name suggests, is a digital asset created directly by the company itself. This can manifest in several ways. It might be manually entered, for instance, when a sales representative keys in a sales order for a smart speaker into an ERP system after a customer calls. That's a direct input. Or it could be automatically generated, such as system logs that record every user login attempt to the smart speaker's companion app, or every command processed by the device itself. These just happen in the background.
Like machine-generated data.
Exactly. We also see electronic data interchange, widely known as EDI. It's a backbone for B2B transactions, really. Business documents like purchase orders, invoices, shipping notices, they're exchanged electronically between computer systems in a standardized format. It minimizes manual errors and speeds up processes significantly. And then there's semi-automatic capture. For instance, when an employee reviews a sales order record that was initially created through optical character recognition, or OCR, scanning of a customer's purchase order PDF, they validate its accuracy and completeness before finalization. So there's a human check, but the initial capture was automated. The goal here is always to get data into a digital format that could be processed.
Okay, that covers internal data. But you mentioned external data acquisition. This sounds like it comes with a lot more, well, fine print and complexities. When you're bringing in data from outside your own controlled environment, what are the biggest added challenges companies face?
You're absolutely right. It introduces a whole new layer of complexity. When data is obtained from an external source, perhaps market research on smart speaker adoption rates, or demographic data from a third-party provider, there are significant added complexities that demand careful management. Foremost among these are concerns about data integrity, ensuring the data hasn't been altered or corrupted during transfer. Then there's its safety from cybersecurity breaches, and critically, intellectual property and copyrights. You're dealing with information that wasn't generated within your controlled internal environment, so you have fewer guarantees up front.
Makes sense. You don't own it initially.
Precisely. Companies often need to sign elaborate contracts regarding usage and privacy with external data providers. These agreements meticulously outline exactly how that data can be utilized, for how long, under what conditions, and what limitations exist on sharing or republishing. It's very detailed. Furthermore, there can be significant, sometimes substantial costs associated with obtaining high-quality external data, especially for specialized market intelligence, competitive analysis, or large-scale demographic information. For our smart speaker company, acquiring external data on competitor pricing or consumer preferences would involve navigating these legal and financial landscapes. This is precisely why the definition stage we just discussed is so crucial. You need to be very clear about the unique value this external data will bring to justify the associated complexities, costs, and risks. You don't buy it just because.
Okay, so once the data is captured, whether it's flowing in from internal systems or carefully acquired from external sources, we move into the preparation stage. This truly sounds like where the real heavy lifting happens, getting the data into a usable, reliable shape, like the cleanup crew arrives.
It absolutely is the meticulous crafting phase, and it's arguably the most critical and time-consuming step in the entire data lifecycle. Industry reports frequently suggest that data professionals can spend up to 80% of their time on this preparation stage alone, which highlights just how messy raw data truly is and why getting this right is often the biggest bottleneck in any data project. The overarching purpose of preparation is to ensure that the data is complete, impeccably clean, current, appropriately encrypted, and user-friendly for subsequent analysis. It's a foundational step, and it's vital to note that both preparation and the next step, synthesis, must be completed before the data is truly ready for analysis or any practical use. Think of it like a master chef preparing ingredients for a gourmet meal. You wouldn't just throw raw, unwashed vegetables or unmeasured spices straight into a dish, right? You clean them, chop them, measure precisely, and ensure they're perfectly fresh and ready. Same idea, but with data.
I like that analogy. So what's involved in this chef's prep for data?
Well, a truly critical aspect of preparation is enhancing the completeness and integrity of the data. Anytime data is moved from one location to another, whether that's from one internal database to another, or when obtaining external data, there's an inherent risk. Risk that some required data could be lost, corrupted, or even manipulated during the capture or transfer process. Things can just go wrong. It is absolutely paramount to determine whether the data is complete, meaning no missing pieces, and that its integrity remains intact, meaning none of the data has been manipulated, tampered with, or duplicated during its extraction or transit. For our smart speaker sales data, imagine if customer addresses were truncated during transfer, or if half the sales records for a particular day simply vanished. That would directly impact billing, shipping, and revenue reporting. Huge problems.
This raises an incredibly important question. How do you even check for that? How do you ensure integrity when data is moving around, especially with huge volumes? It sounds like finding a needle in a haystack.
It can feel like that, but there are systematic ways. There are 4 specific, essential validation steps that should be rigorously completed for captured data. First, and quite simply, you compare the total number of records you intended to capture with the number of records actually present in the source database, or the number that arrived. This straightforward check immediately reveals any potential missing rows of data. If your source had 10,000 smart speaker sales records and your captured file only has 9,990, you immediately know something went wrong.
Okay, simple row count. Makes sense. What else?
Second, if you have access to checksums or can compute descriptive statistics from the original data source, you compare those statistics for numeric fields. For instance, comparing sums, averages, or standard deviations of a sales amount column between the source and the new file. This can instantly tell you if data is missing or incorrectly formatted, even if the row count matches somehow. If the total sum of sales in the new file doesn't match the source sum, you have a problem. Data got changed.
Ah, clever. Checking the numbers themselves.
Third, you validate that field formats are consistent with the source. This means checking if a field intended to be a string or text, a date, a time, or a number, like a double for currency or an integer for quantity, has maintained that format appropriately. Imagine if your purchase date field suddenly became a string of random characters instead of a proper date format. That would break any date-based analysis or reporting immediately. And finally, fourth, you compare character limits for the attributes in the source file to the new file. This ensures data was not lost due to mismatched character limits. For example, if a customer's shipping address field in the source could hold 100 characters, but your new system only allocated 50, well, the latter half of many addresses would be truncated and lost, leading to failed deliveries and very frustrated customers.
Yeah, definitely want to avoid that. So validation is key. What else is part of preparation?
Beyond validation, data integration is another crucial component. especially when external data is sourced, like those foreign exchange rates for international sales, or maybe demographic overlays for marketing. In such cases, it is critical to design the underlying data architecture to ensure that the data pipeline, which is essentially the automated path data travels from its source to its destination, is robustly integrated with the target location or database. This integration must ensure that any ongoing updates from the external source are loaded both timely and accurately into your target system. You need those foreign exchange rates to be current, right? Not from last week, to make good financial decisions about your global smart speaker sales. This involves setting up reliable APIs, automated scripts, and robust error handling in case something breaks during the update.
Okay, so once it's complete and integrated, validated, and pipelines are set, it still needs a good scrub, right? Cleaning data sounds like it could be a massive, never-ending task, like trying to clean up after 1,000 toddlers threw spaghetti everywhere.
It can certainly feel that way, but it's absolutely vital for data quality and the ultimate reliability of your insights. It's unavoidable work. After validating completeness and integrity, the data needs to be thoroughly assessed for quality in preparation for analysis. There are 5 essential steps, typically, for cleaning captured data. First, you need to remove any unnecessary headings or subtotals that might exist within the raw data. These often appear in legacy reports or poorly structured exports and can obstruct proper data synthesis or analysis. They get mistaken for actual data points, leading to incorrect calculations.
Right, get rid of the extra stuff that isn't actual data.
Exactly. Second, you clean leading zeros and non-printable characters. For instance, if product IDs are supposed to be 00123, but some appear as 123, or if hidden control characters are present from a messy data export, they need to be standardized. Ensures consistency across data values. Otherwise, your analytical software might treat 00123 and 123 as different items, leading to inaccurate inventory counts or sales figures.
Consistency is key.
Absolutely. Third, you format negative numbers to ensure consistency across numerical values. Some systems might represent negative numbers with a minus sign in front, others in parentheses. This inconsistency can cause analytical tools to misinterpret them, leading to errors in financial calculations or performance metrics. Standardize it.
Got it. Standard negative numbers.
Fourth, you must identify and correct general inconsistencies across data. This is particularly important for categorical data where the same concept might be represented in multiple ways. For example, if you have a state field for customer addresses, California could be formatted as CA, Cal, California, Califor, and so on. Before analysis can effectively group data based on that attribute, all these variations need to be identified and replaced with a single common standardized value like California. This isn't just about tidiness, it's about business continuity. Seemingly minor inconsistencies can completely derail a multi-million-dollar marketing campaign if your analytics system can't correctly group your customers by state. Leads to inaccurate ROI figures, wasted spend.
Oh, yeah. Those little inconsistencies add up.
They really do. And fifth, you address inconsistent data types. Sometimes a field that should inherently be a date might be imported as a plain string of text or a number as text. You need to ensure data types, date time for timestamps, doubles for currency, strings for text, integers for quantities are correct. Trying to perform a calculation on a string value that represents a number will just result in an error. So this step ensures compatibility with analytical tools and prevents crashes or miscalculations downstream.
So much checking and fixing. Anything else in preparation?
Yes, one last crucial piece, encryption. Due to the inherent sensitivity of much business data, from customer credit card details to proprietary sales figures, and the overarching concern for data integrity, encryption is generally required. It's usually not optional. This applies to data both in transit as it moves across networks, for example, when an employee accesses a database remotely, or when data is transferred to a cloud service section, and when data is at rest, meaning stored on servers, hard drives, or in cloud storage. Encryption adds a crucial layer of security, protecting the data from unauthorized access or tampering throughout its journey in storage. This is non-negotiable for compliance, like with GDPR or IPAT, and just for safeguarding sensitive information.
Wow, that's a lot of meticulous work in preparation. Okay, after all that heavy-duty prep, we arrive at step 4, synthesis. What's this stage all about? It sounds like putting everything together, maybe creating something new from the clean data.
That's a good way to think about it. Synthesis acts as a crucial bridge between the detailed preparation we just discussed and the ultimate usage of the data. It's the stage where, once you've determined how you intend to use the captured and prepared data, you can create calculated or derived fields. The goal is to prepare that data for quicker, more efficient usage and analysis later on. Now, synthesis is not always a necessary stage for every dataset. Sometimes the raw, meticulously prepared data is sufficient for direct analysis, but it becomes invaluable when existing data can be combined, aggregated, or transformed into new, more useful metrics or dimensions. It's about enhancing the data's utility by deriving new, often more insightful information from existing fields, optimizing it for its analytical purpose.
Can you give an example?
Sure. A very clear example of data that can be synthesized would be the creation of a net sales calculation for our smart speaker company. You might have existing raw fields for gross sales from your order system, right? And then separate fields for sales returns, allowances, and discounts from your accounting system. Instead of requiring every analyst to perform this calculation, gross sales minus returns, allowances, and discounts every single time they want to look at net sales, well, that's inefficient and error-prone. So the synthesis step involves creating a new persistent field. This synthesized net sales field is automatically calculated and added to the dataset. It becomes readily available for all subsequent reports and dashboards, speeding up analysis and ensuring absolute consistency across all reports that rely on that crucial metric. Other examples could include calculating customer lifetime value derived from purchase history and engagement data, or figuring out the profit margin per product by combining sales and cost data. It essentially transforms raw ingredients into ready-to-use components for your analytical recipes.
Ah, I see. Pre-calculating useful stuff. That makes a lot of sense. Okay, so that brings us to step 5, analytics and usage. This is where the magic happens, right? Where all that meticulous hard work finally pays off. Data in action.
Absolutely. This is the payoff phase. Once the data has been thoroughly prepared, cleansed, validated, and potentially synthesized, it is truly ready for practical, meaningful use within the organization. This primarily involves leveraging the data to create insightful reports, dynamic dashboards, maybe sophisticated analytical models, and most importantly, it's about using these insights to inform critical business decisions. That's the ultimate goal. For our smart speaker company, this might mean analyzing sales trends to decide on production volumes for next quarter, or understanding customer support call patterns to identify bugs or improve product features, or maybe segmenting customers based on their usage to tailor marketing campaigns more effectively.
So this is where the insights actually happen.
Exactly. This stage of analytics and usage lasts for as long as the data remains valuable and actively useful to analysts and decision makers within the company. It's an ongoing phase for active data. For example, monthly sales data might be actively used by the sales team to track performance against targets. Marketing might use it to understand campaign effectiveness and optimize ad spend. Finance would use it for accurate revenue forecasting and budgeting. What's fascinating here, and a key distinction, is this. If data isn't going to be shared externally yet, it remains primarily in this phase, dedicated to internal company use. The focus here is entirely on supporting the internal operations, strategic objectives, and competitive advantages of the business. It's about turning data into actionable intelligence for the company itself. This stage often involves sophisticated tools, for business intelligence, data visualization, and advanced statistical modeling. Moving from descriptive analytics, what happened, to diagnostic, why it happened, predictive, what might happen next, and even prescriptive analytics, what should we do about it, it gets quite advanced.
Okay, so we've covered the internal life and use of data. But if it's not just for internal use, what happens next? Eventually, some data needs to leave the company's internal walls, right? That brings us to step 6, publication, sharing it with the outside world.
That's absolutely correct. Publication occurs when prepared data, which was previously only for internal consumption and analysis, is now strategically shared with external users or stakeholders. This is a significant and often irreversible transition in the data lifecycle. Once it's out, it's out. We see this in countless common business activities. For example, when our smart speaker company sends monthly statements to its clients detailing their account activity or invoices for subscription services, that's published data. Or when the company publishes its quarterly or annual financial statements, making them available to investors, regulators, or the general public. Very common form of publication. Or even when a sales team sends a detailed, customized quote to a potential customer outlining product configurations and pricing. That quote is published data. In all these instances, carefully prepared data is being released beyond the company's direct proprietary control.
And that loss of control sounds like a big deal. What are the implications?
The critical implication here is profound. Once data is published, the internal company no longer has sole control over how that data will be used. It's gone into the wild, so to speak. The company cannot dictate whether it will be further shared by the recipient, how it might be archived by them, or even how it might eventually be purged from their own systems. This loss of exclusive control necessitates extreme care, scrutiny, and robust governance in deciding what data is released externally. Companies must be acutely aware of privacy regulations like GDPR or CCPA. Releasing the wrong data can lead to massive fines. They also need to consider potential competitive disadvantages that could arise from disclosing too much sensitive information. And of course, there are significant reputational risks associated with externally published data, as its trajectory beyond this point becomes far less predictable and manageable. Each piece of published data needs to be assessed for its legal, ethical, and competitive implications before it ever leaves the company's systems. It requires careful sign-off.
Okay, so publication is a major step with big consequences. Now, eventually, even published data or data used internally isn't actively being used or referenced daily anymore. It doesn't disappear immediately, but it sort of moves to the back burner, doesn't it? That brings us to step 7, archival.
Precisely. Archival is the process of intelligently managing data when its immediate active need declines. It's like moving things from your main desk into a filing cabinet or storage room. This involves moving specific data sets from active, frequently accessed systems, which are typically optimized for rapid access and processing, and often more expensive, to more passive, often less expensive, long-term storage systems. Good examples include old financial data that is past the relevant analytical period set by the company, maybe 7 years ago, or historical customer purchase records that are rarely accessed but might be needed for, say, long-term trend analysis someday. Or perhaps large data sets that are infrequently utilized for an extended period but cannot yet be discarded due to regulatory requirements or some potential future use case.
Why bother archiving? Why not just keep it all active or delete it?
Well, there are several compelling strategic and operational reasons for archiving. Primarily, it helps to free up valuable, high-performance storage resources on active systems. Storage isn't free. This, in turn, significantly enhances the performance and speed of those active systems because they're not burdened by vast amounts of historical or infrequently used data they have to sift through. Additionally, moving less frequently accessed data to archived storage can reduce security risks. It decreases the amount of potentially sensitive data residing on systems that are more frequently exposed or accessed by a wider range of users. It's a cold storage approach to data security. Now, optimally, archived data will be thoroughly tested for accuracy and completeness prior to its removal from active systems. You don't want to archive corrupted data. This verification step is absolutely critical, as you want to ensure that if you ever need to retrieve that archived data in the future, perhaps for a legal audit or an unforeseen historical analysis, it is fully intact, uncorrupted, and perfectly usable. Otherwise, the entire archival effort would be futile, and retrieving valuable information when you suddenly need it would be impossible.
Right. Check it before you store it away. Makes sense. And finally, the very end of the line for data. The digital equivalent of a final curtain call, or perhaps a digital shredding party. Step 8, purging.
Indeed. Purging marks the definitive and irreversible end of the data lifecycle. It is the complete and permanent removal of data from all of the company's storage systems, both active and archived. This is not just moving data to another location, like the recycle bin. It's deleting it permanently, often with processes that make recovery virtually impossible, like shredding a document versus just throwing it away. There are several critical considerations here that companies must navigate with extreme care before hitting delete.
Such as, what do you need to think about before purging?
First, it's absolutely essential to ensure that the data has truly reached the end of its usefulness to the business. Is there any conceivable analytical or operational reason to keep it, even archived? Second, and perhaps even more importantly, you must meticulously confirm there are absolutely no legal, regulatory, or other compliance requirements that mandate maintaining that data for a longer period. This is huge. For instance, financial records related to our smart speaker sales might need to be retained for 7 years by tax law in some jurisdictions, or certain customer data might have specific retention periods under privacy regulations like GDPR. You must keep it for that long. Violating these retention requirements can lead to severe fines and significant reputational damage. Once those criteria are meticulously met, and it is truly time to purge the data, it is absolutely critical to ensure that the data is completely purged. This means ensuring it's removed not just from primary databases, but from all backups, redundant systems, offsite storage, and even cloud-based mirrors. It has to be gone everywhere. This can be a complex technical challenge, often requiring specialized tools and documented processes to ensure no recoverable traces remain, safeguarding against future data breaches or compliance failures years down the road.
Wow. So even deleting data is a complex, careful process. We've walked through the whole life cycle now, from its very beginning to its absolute end. It's a far more complex and strategic journey than most of us realize. But that raises another crucial question. How does data actually get collected in the first place? What are the main ways it initially enters this incredible cycle we just described?
That's a crucial follow-up, yeah, because the method of collection often profoundly influences how the data will flow through the subsequent life cycle stages. It impacts everything from its initial cleanliness to its security requirements later on. Our sources identify three primary, distinct methods of data collection: extract, transform, and load, widely known by its acronym ETL, active data collection, and passive data collection.
Okay, let's break those down. What's extract, transform, load, ETL?
Right. ETL is a specific, highly structured method primarily used for collecting and integrating existing data. That data could be internal to your organization, maybe sitting in an old legacy system, or it could originate from an external source, like a vendor's product catalog feed. The fundamental goal with ETL is usually to answer a particular data analysis question or to populate a data warehouse for broader business intelligence. It's very process-driven. It's a highly structured three-part process. First, extract. This is where data is pulled or read from its original source. This could be a traditional relational database, a flat file like a CSV or Excel spreadsheet, or even pulled through an API from another system, just getting the raw data out.
Okay, extract, then transform.
Second, transform. Once extracted, the raw data is converted into a useful, consistent format suitable for analysis in the target system. This step is where much of the preparation and synthesis from our life cycle discussion really comes into play. It overlaps significantly. It often involves cleaning the data, removing inconsistencies, handling missing values, standardizing formats like dates, units of measure, combining data from multiple sources, maybe merging sales data with customer demographics, and generally preparing it for the specific structure needed in the target system. Think of it as meticulously shaping the raw clay into a perfectly usable form for your artistic creation. That's the transform stage.
Got it. And finally, load.
And third, load. Finally, the transformed and cleaned data is put into the chosen analysis tool or target database. This could be a data warehouse, a data mart, or a business intelligence platform. This step makes the prepared data readily available for querying, reporting, and analysis by the end users.
So ETL sounds quite similar to some of the lifecycle steps we just talked about, especially capture, preparation, and synthesis. Are they deeply related? Or is ETL something entirely different? It feels like there's a big overlap there.
That's an excellent observation, and you're absolutely right. There's significant overlap. They are very closely related concepts. ETL shares strong similarities with the capture, preparation, and synthesis steps within the broader data lifecycle framework. The extract part of ETL clearly aligns with capture, as you're obtaining the data from its source. The transform part inherently encompasses many aspects of preparation, cleaning, validating, formatting, and also synthesis, creating new fields or combining data.
So what's the difference then? Why have both terms?
The key distinction is this. ETL is a more specific methodology or technical process. It's used for collecting and preparing existing data, typically performed for a particular analytical purpose or to systematically populate a data warehouse or data mart. It's a defined pipeline. It's a structured process within the broader data lifecycle. The data lifecycle, on the other hand, is a broader, overarching framework or philosophy. It describes the entire journey of all business data, from its very initial concept definition all the way to its ultimate disposal, purging. While ETL is a powerful tool frequently used to manage data through the capture, preparation, and synthesis phases, especially when integrating data from disparate sources, it's a specific technique rather than the full philosophical scope of data management. And what's also fascinating is the evolution here. While ETL has been a cornerstone for decades, we're seeing a massive shift towards ELT extract, load, transform, especially with the advent of powerful cloud data warehouses. The load-first approach allows you to dump raw data into the warehouse and then scale computation to transform data in situ within the warehouse itself. This offers much greater flexibility and speed for agile analytics, and it's fundamentally changing how organizations think about their data pipelines.
ELT instead of ETL. Interesting shift. Okay, that clarifies EPL. Next up, active data collection. This seems like the most straightforward and transparent method of getting new data, doesn't it? You just ask for it.
It is indeed the most direct method. Active data collection is exactly what it sounds like. You directly and explicitly ask users for new data. Those users could be your employees, your customers, or general users of a service. You are actively engaging with them to solicit specific pieces of information that you need. There's a clear intent to gather new data from the user, and the user is typically, or should be, aware they are providing it.
What are some common examples?
Oh, they're very familiar to all of us. Think about the results you get from customer satisfaction surveys. You ask a series of structured questions to gather opinions about your smart speaker's performance or maybe some demographic information. That's active collection. Or the findings from in-depth user interviews, which might be more qualitative and deep, gathering specific experiences or perspectives on using the product. Still active. It also includes the very common scenario of forms that gather personal information, like when a customer signs up for your smart speaker's online service and provides their email address, phone number, or physical shipping address. In all these cases, the user is consciously and directly providing the data you are requesting. It's a transparent, ideally permission-based exchange of information where the user knows what they're giving and usually why.
That seems pretty straightforward. You ask, they tell. Transparent, as you said. But then we have the third method, passive data collection. Now, this is where it really gets interesting. And for some listeners, perhaps a little bit like Big Brother is watching. How does this work, and how do companies gather information without directly asking?
Right. Passive data collection is fundamentally different because companies gather information without direct, explicit permission from users in that traditional ask and give scenario. It happens more in the background. This method leverages the increasing connectivity we see today, particularly through web technologies, the Internet of Things, IoT, and advanced artificial intelligence. Instead of asking, the data is quietly observed and collected from user interactions and digital footprints as they happen. The user might not even realize it's being collected, or might have only agreed in very broad terms of service.
Can you give some examples of passive collection?
Sure. Common examples include tracking web usage via cookies. Cookies are small data files stored on your computer by websites you visit. They allow the website to remember information about you, like your login status or items in a shopping cart. That's the convenience side. But more broadly, they track your browsing behavior. Which pages you visit on a site like our smart speaker company's e-commerce store, how long you stay on a product page, what products you click on, or what search terms you use within their site. Another pervasive example is gathering timestamps of when users interact with your website or online store. Literally the exact moment someone clicked a Buy Now button, viewed a product page, or completed a purchase. This allows companies to build a detailed, often initially anonymous, picture of user behavior, preferences, and engagement patterns without ever directly prompting the user for that specific interaction data. It's often used for website analytics, personalization, like suggesting products based on past browsing and generally improving the user experience. But the user didn't actively give that click data, it was just observed.
That's a huge distinction in how data is acquired, asking versus observing. So understanding how these different collection methods work, whether it's the structured, pre-planned ETL process for existing data, the direct engagement of active collection, or the more subtle background nature of passive methods. How do they fundamentally connect to and influence the initial definition and capture stages of the life cycle? Do they change how those early stages are handled, or the challenges you face right from the beginning?
This raises an incredibly important question, yes, because the method of data collection profoundly informs how diligently you must approach the subsequent preparation and validation steps, and indeed, the entire data lifecycle. It sets the tone. For passive collection, for instance, there's often less explicit user intent behind the data point. The data might be inherently noisier, more unstructured, and potentially less clean than actively provided data. People click things accidentally. This means it requires even more rigorous cleaning, standardization, and careful validation during preparation. If you're tracking website clicks, you'll have to filter out bot traffic or accidental clicks, which isn't really an issue if someone manually enters their address correctly.
So passive data means more prep work later.
Often, yes. And for external ETL, issues of source integrity, the quality of data coming from a third party, and copyright considerations become paramount right at the capture stage. You need robust contracts and very strong validation checks as soon as you extract it to ensure the data you're pulling is accurate and legally usable. Whereas active collection, while generally more transparent and often cleaner at the point of entry, still requires careful consideration. You have to think about potential data entry errors by the user or biases in survey responses. For example, people answering surveys in a way they think you want to hear rather than their true opinion. That's a quality issue we need to account for. So yes, the method of collection directly dictates the specific challenges, the technical requirements, and the strategic priorities you face in ensuring data integrity, quality, security, and crucially, compliance with privacy regulations as you move through the rest of the data lifecycle. It's like the first ripple in a very long chain reaction. Knowing the source informs everything that follows.
Wow, what an absolutely incredible journey we've traced today. From a meticulously defined need, through its active life of cleaning, synthesis, and usage, to its final responsible purging. The data lifecycle truly is a complex, detailed 8-step process, way more involved than I think most people realize. We've seen why each stage is not just important, but absolutely vital, from the careful, often painstaking art of preparation and cleaning that eats up so much data professional time, to the weighty decision of publishing data externally, and the critical, often legally mandated act of purging it completely. And we've explored how data even gets to us in the first place, whether through the structured ETL process for existing data sets, the direct engagement of active collection, or even subtly in the background with passive methods like cookies. It's fascinating.
Indeed. What's truly striking here is how interconnected every single step is. You really can't isolate them. A failure in one stage, particularly preparation where data is validated, integrated, and cleaned, can have a catastrophic ripple effect through the entire cycle. It can fundamentally compromise the integrity of analytics and the very decisions made from that data down the line. If your data isn't complete, accurate, or clean at the outset, then any analysis performed on it, no matter how sophisticated the tools you use, will be flawed, inherently flawed, leading to potentially misguided strategies, financial losses, missed opportunities, and poor business outcomes. This deep dive should really highlight the immense strategic and operational responsibility that comes with managing data effectively. It underscores why it's not just a technical process handled by IT in the back room, but a fundamental strategic imperative for any modern organization hoping to thrive in a data-driven world. It needs board-level attention.
Absolutely. So the next time you interact with a company online, maybe make a purchase with your smart speaker or fill out a simple form. Perhaps you'll think about the incredible, intricate journey your data is about to take behind the scenes. It's quite something. It's not just about collecting information. It's about cultivating knowledge, ensuring its quality every step of the way, and managing its entire existence with precision and care. For you, the learner, the takeaway is clear. Understanding this cycle is a true shortcut to recognizing the hidden architecture of the digital world, and it helps you see how savvy organizations truly harness their most valuable asset for competitive advantage and sustainable growth.
And this raises an important question, maybe a final thought for you to consider. In an increasingly data-driven world, where information is constantly being generated and processed all around us, how does knowing this intricate data lifecycle empower your critical thinking about the information you encounter daily, and perhaps even about the data you yourself generate and share, maybe without always thinking about it? How might this understanding change your perspective on things like data privacy settings, or perhaps the reliability of the news or statistics you consume online?
Something profound to mull over, definitely. Thanks for joining us on this really insightful deep dive. Until next time, keep digging for those nuggets of knowledge.